Hi, this is Wes Simpson on behalf of the RIST Forum, welcoming you to our presentation on RIST technology and applications. My current position is founder of a company called LearnIPVideo.com. I think it's obvious what our company does. And I'm also the co-chair of the RIST activity group within the Video Services Forum, kind of the group that got a lot of this stuff started. With me today is David Griggs, who's a senior product manager from AWS Elemental, and he's going to share some insights from his perspective on how RIST is working and the types of things that we've been doing in the cloud and in other places to really make RIST technology a part of, I think, everybody's future.
Hey Wes, everybody. Good to be here. Thanks for having me.
Really glad to have you, David. You know, one of the things that I get a lot of questions about, I don't know about you, are, you know, why do we need a new standard? Why do we need a new specification? And
Absolutely.
There's, you know, so I like to think about the world of internet video in three different categories. So on the first category, I consider consumer technologies, and I'm a big believer in them. I'm using them every day. I think they work great, and they're very good for person-to-person communications, for holding webinars, for holding meetings and things like that. And there are technologies like Zoom and Skype and, you know, some of the Google Meet capabilities, things like that. And to me, what really distinguishes them is that they are primarily links from one person's device, whether it's a PC or a mobile phone or what have you, over to another person's device or several people's device. So I kind of call that consumer quality, okay? Then a lot of organizations have moved on to business quality. Now, those are the ones where you might have multiple users, you have lots of control over different accounts. You might have some rooms set up specifically for video conferencing and things like that. So things like GoToMeeting, Microsoft Teams, you know, those types of technologies, GoToWebinar, are all, you know, very much in the mix. But again, they're still device to device. You're using a camcorder, you're using, or a webcam, you're using something built into a laptop, etc., and you're displaying the video on another person's screen. To me, RIST is really meant to attack the broadcast quality market. Now that's where we're starting to talk about devices and services that are used for producing professional quality video, something you might watch a football game using, or something that you might use for a breaking news report, or something that you might just use to produce from home when you're, you know, in the time of a pandemic. And the big difference there is that you're using native video input and output. So you've got video coming from a camera, a studio quality camera, feeding through the RIST system, and then the output is to a studio quality production system or some sort of high quality recorder. Fixed delay, a lot of times it's one way from its source to a destination. And to me, the best example of what's going on with that is RIST. Now, you guys have been in this market for a while now, right?
Yeah, absolutely. And I think this is a really good slide. It really characterizes well where RIST and technologies like it are different from the consumer grade and to some extent the business grade products. I mean, for us, broadcast quality means mezzanine encoded quality content. It's typically a B2B type operation. And to your point, this is like tier one video inputs and outputs. So really high quality. And it's this that's the lifeblood of the television industry, right? It's this kind of content that we distribute globally through all sorts of technologies today that becomes the lifeblood and becomes the seed of what ultimately we watch on television at home. And RIST is a way for our customers to think about terrestrial ways to deliver this content, whereas they might previously be using things like satellite. So yeah, this is a great slide.
So just another little picture here, you know, sort of separating out the contribution, distribution, and delivery portions of the professional video market. And really where RIST plays is in the contribution and distribution phase. RIST really isn't meant to go to the ultimate consumer. It's obviously creating video that millions of eyes are going to watch, but it's really meant to get content from a venue to a broadcaster, or to get content from a broadcast network out to their distribution partners, the folks like cable TV companies or over-the-air broadcast companies, or a CDN that might be distributing a stream to 10 or 20 million people for a large live event or something along those lines.
I think another great example might be, a major network needing to distribute their content to affiliated stations or owned and operated stations around the country as well. So I think that's another.
Yeah, and we're actually seeing a lot of traction in that market. We're seeing a lot of people that are moving towards trying to get off the satellite, not only because of the issues associated with delays and things like that, but there's a big issue about some of the spectrum going away. For some of the valuable spectrum that broadcasters have used for many years is going away very soon, and they've got to get off those C-band satellites. So
that's right.
It'll be interesting.
Yeah, I think that's super interesting. I think C-band reallocation here in the United States, at least, is a big motivator. I think that the alternatives, when you think about satellite technology, you're talking about KU. That's a narrow dish technology that's much more susceptible to things like rain fade and weather interruption. And so there is no real good satellite replacement for C-band, in my opinion. And that's why terrestrial technologies, IP technologies, and initiatives like RIST are going to be so important to our industry moving forward.
I think you're absolutely right. I think it's going to be great. So since I was there at the beginning, I thought it might be a good idea to just talk about why we did RIST in the beginning. First of all, we had some goals. We wanted contribution quality, so the best stuff that you can get, but we wanted to do it over the public internet. We didn't want to have dedicated networks anymore. We wanted to be able to use something that's going to survive going through the public internet. And it had to be interoperable, so that if you buy equipment from vendor A, it's going to work from vendor B. We didn't want to have the special sauce anymore, all these different brands that had no mixing. Low latency. And we wanted the latency to be deterministic, which is kind of an unusual thing. But what that really means is that we know that there's going to be delay, but we don't want the delay varying dramatically from one scene to the next, or from one camera to the next. We want to know that when we put the video in here and when it gets delivered there, it's always going to be the same amount of delay. That's really important for a broadcaster. I bet you're seeing that pop up in some of your customer applications. They're asking you to, get away from, our delay is somewhere between 5 and 30 seconds. I don't think that cuts it for most broadcasters.
No, I think, but you hit the nail on the head here, right? It's not so much, of course, low latency is important. And particularly when you're talking about content such as sports, where everyone wants to watch that as close to real time as possible. But what's more important is the deterministic aspect of it. It's so critical that you can count on the latency being fixed for these broadcast applications, particularly in contribution applications. The broadcasters would rather have slightly further delayed content, as long as they can guarantee that latency is consistent and deterministic. That's by far the more important factor.
Yep. And then the other goal is to, eliminate the impact of any defects that happen along the way. I mean, we are talking, a lot of these applications are public internet, although RIST will work fine over leased lines and other private IP circuits, but we've got to be able to deal with the fact that, yes, we're going to lose some packets from time to time on the public internet. So the idea behind RIST is that we wanted something that worked over hardwired internet, mobile data connections, bonded LTE circuits. So, if you've got cellular bandwidth to your application, we want to have RIST to work. And ideally, we'd like it to be able to work over a satellite link with, suitable delay settings. So there's a lot of work going on to make RIST, suitable for all those different applications.
I think that speaks to the standards-based approach for RIST. The fact that it's heavily utilizing RTP, which is a well-established IP standard. It makes it so suitable for multiple different forms of physical transport.
Absolutely. So in case people don't know, I mean, losing packets is a bad thing for video. Hopefully that's not news for most of our audience, but maybe it is. But just losing one IP packet with video, you can get macro blocking across a frame. You can corrupt multiple video frames. We can even temporarily lose video sync. And actually, where packet loss is even more noticeable on some broadcasts is in the audio feeds. Audio tends to die more quickly and be more sensitive to packet losses than even video. One of the reasons why you don't see a lot of this at home for a lot of your home delivery applications is that a lot of decoders will mask those video losses by repeating frames. You'll see, to the viewer, it looks like your video freezes and unfreezes a lot. That's your decoder trying to compensate for the fact that some of the packets are missing along the way. A big problem with some of the internet delivery protocols, but not with RIST. So here's just a real quick table to show you, why we have to worry about losing packets. This is a 5 megabit stream, which running at about 500 packets per second. And if we work in the typical internet, open, uncontrolled internet, we're looking at maybe a packet loss ratio of 10 to the minus fourth, 10 to the minus 5, which means we're losing 1 out of every 10,000 packets or every 100,000 packets. Well, that might not sound bad, but that means we're going to be taking a hit at 10 to the minus fourth every 20 seconds. We're going to have something, we're going to lose a packet that we're not going to be able to recover. When that happens, you could see the video glitch, you could hear an audio glitch, or any of those other problems could actually happen. So what we're saying is that when you're on the internet, you need to be able to fix these kinds of problems. So let's talk about some of the things that people have developed into RIST, using RIST technology, have developed into products. Well, first of all, they've got low fixed end-to-end delay systems, like we were just talking about. That determinism is so important to broadcasters. They have devices that will take in SDI, HD SDI, or even 4K video, as well as all of the new 2110 IP standards for video, audio, ancillary data, things like that. Most of your RIST devices will also be able to handle, and most of them do compression, but they may also take a compressed stream in directly. So MPEG-2 transport streams, or basically anything that's coming out of a broadcast quality encoder or decoder. And the other thing that's really weird about RIST applications is you need more than just video and audio. A lot of times you need controls for your camera. You need an intercom so your camera operators can talk to your directors. And you also have to carry the extra signals that broadcasters use to indicate when ads are going to be inserted, when captions are going to occur, and the time code for the videos. Now, you guys do a lot of work with captioning already, on the AWS platform.
Yeah, I think this is one of the advantages of Transport Stream for us, and therefore RIST's compatibility with Transport Stream is that it's more than just video and audio. To your point, there is this what I would call ancillary data. That's probably showing my age a bit, but that covers a whole bunch of additional metadata that's pertinent and time sensitive to the stream, but isn't directly related to the audio visual experience.
Yeah, and a lot of times, lower end systems will strip that out because you don't need it to hear or see, but you need it to make money. You got to have those captions. You got to have that ad insertion.
Well, particularly for the SCUDdy, like the SCUDdy 35 marker workflows, that's the lifeblood of so much commercial television. In fact, all commercial television is based on revenues coming from advertisements. So without that, you're definitely stripping out a lot of value from the signal. Exactly.
And going back to what you were talking about in the distribution, getting the signals out to the broadcast affiliates. So just a little history on RIST. It's actually a fairly new technology compared to some of the other things we've been talking about. The activity group convened in early 2017. We had some early documents come out in April and May of 2018. We did some interoperability testing. We've published those. Those are out, freely available to anybody on the vsf.tv website. And anybody can download them. We've done some public interoperability testing at various trade shows when we used to be able to go to those. Remember that? we have, so the simple profile was published in October of 2018. We started seeing a lot of commercial products at NAB 2019. That fall, we also had another interop at IBC for main profile codecs. And then we published that spec in March of 2020. The thing to remember here is that when we say interop, it's not just one company proving they can talk to another company. It's multiple companies working together and doing round robin testing and making sure that A, B, C, and D can all talk to E, F, G, and H. It's not just one-to-one, one simple little interconnection there. And I know we've used a lot of AWS resources for doing the latest round of interops because we haven't been able to get together in person.
That's right. Yeah, I think interop is such a key part of this, right? I think as an industry, we're used to interoperability. Like if you think about how we used to, and to some extent still do, build broadcast facilities, they're based on standards. They're based on things like Serial Digital Interface 2110, 7022-6. I mean, these are all standards that have been specifically engineered to help end customers build environments that meet their needs and potentially across multiple vendors and multiple providers. And so to have this kind of capability in long haul distribution technology like RIST, I think is critical and really beneficial to the end customers. And frankly, we're starting to see that our customers are thrilled about there being now a truly interoperable standards-based approach for content distribution.
So one of the things I know you're going to be talking a little bit about later, but the RIST standard has evolved over time. The first generation that came out was simple profile, shown here on the left in the green column, and then we have the main profile in the red column. Those came out. I mean, the main profile has only been out for a few months in 2020. I just wanted to really explain the high level differences between those two, so people know why they're different and why people are making the migration. But simple profile was able to do things like media synchronization, was able to recover from lost packets using this NAC-based ARQ technology, which is two great little acronyms. It did seamless switching, so if I had two paths that I was sending the same signal down, I could switch from one to the other without losing any packets along the way, seamless switching. And then in 2020, we actually tweaked that standard, that specification a little bit to add an echo message that allows you to measure round trip time, which is very important for setting your buffers. Main profile adds encryption. That's one of the really big important features that was implemented. And this is encryption that will work from, again, vendor A to vendor Z. It's not specific to an individual corporation. So we have DTLS encryption, which is point-to-point, very much like the secure HTTP that a lot of us use every day on the World Wide Web, but also pre-shared key or PSK encryption, which supports multicasting. So a broadcaster can take one signal and send it to hundreds of different locations without having to encrypt the stream specifically for each one of those endpoints. So there's a big savings there. We do GRE tunneling, which means I can put multiple streams over the same internet connection and treat those packets in a common envelope. Null packet deletion, which just means that if I've got a null packet, I don't have to send it across my network. The ability to support high bitrate streams, and then some JSON capability to give RIST even more flexibility. So right now we've just published within the past month and a half the RIST compatibility levels document. So we have at the base, everybody has to support simple profile to be called RIST. Then we have a baseline level of RIST main profile, two different encoding stacks, and then the full level really shows you all the capabilities of the main profile, including both the point-to-point DTLS encryption, the pre-shared key multi-point encryption, and all the extra goodness that we put into RIST when we made the advanced profile. So I'm not going to dwell on this slide, but if you look at it, one of the things that was a real driver for the RIST activity group was to make sure that we used industry standards as much as we possibly could. And this is a list of a lot of the standards, certainly not all the standards that are included in RIST, but you can see that building on existing SMPTE specifications and Internet Engineering Task Force standards really allowed us to build a very powerful system, but not have to reinvent the wheel, not have to cause people to create all kinds of new technology.
It's wonderful, isn't it, that you get enough existing standards that you can build something new and wonderful without having to go out and invent a whole bunch of new stuff, right? It just shows you how well these standards have been designed to work together to produce new and interesting technologies like RIST.
Yeah, it's been, you know, and we have done a little inventing where we had to, but not a heck of a lot. So that's really saved things, and it's also made it easier for companies to implement.
Right. And it talks to the interoperability as well, right? Because of that wealth of existing standards that form the basis for RIST.
And here are a selection of the companies. I think we're getting ready to publish a press release that's talking about, I guess, over 100 different members of the RIST Forum. You can see the leading members at the top, the associate members down below, but many companies have participated in this RIST Forum, in developing the RIST specifications published by the VSF, and they're going now to actually implement those. So they're building products. They are using the open source code that's available in a bunch of different places, and really we're getting to the point where we have a very rapidly growing groundswell of support for RIST technology to make it so that you don't have to work as an island anymore. So it's really, I think it's really proceeding nicely. And speaking of how nicely it's proceeding, I'm gonna, you know, let David take the lead here for a little bit and talk about some of the great things that are going on in AWS Media Connect today.
Yeah, thanks, Wes. I mean, firstly, yeah, I think, you know, from our perspective, you know, well, Media Connect really is just a service that it plays in the distribution space, and for us, RIST is fundamental to that effort. So why is RIST so important to AWS today? If we can go to the next slide, Wes, that'd be great.
Sure.
I can control. Thank you. Yeah, I think, you know, for us, you know, there's a couple of things, right? So AWS, you know, is a managed network, but our customers don't always live at least inside of that network. They work from on-prem locations. And I think to Wes's point earlier about the types of devices that utilize RIST today, they're not all purely software-defined products. They live on-prem. They're cameras. There are encoders. There are other pieces of hardware that deal with, you know, on-prem standards like SDI that exist on-prem, and we want to recognize that, and we want to embrace that. And so technologies like RIST allow us to be agnostic to some extent about the connectivity between those on-prem devices and AWS and services like Media Connect. So for us, the idea that our customers don't have to think about one standard for reliable internet contribution to AWS or reliable internet distribution from AWS, and then a whole different set of protocols and standards for transfer within our network is really compelling. And our customers really resonate with the idea that they have a one-stop shop solution for reliable video over IP workflows. And that's something I think has become very clear and very important to us. Of course, you know, we've talked a little bit about this already, Wes, but for us, the standards-based approach is key. You know, this is an open standard. It's being charged by the VSF. You know, we see it going, you know, you know, in the right direction from a standards perspective. And what does that give us? Well, it gives us some confidence. It also gives us the best shot at interoperability because we're all reading from the same spec. You know, so there's no ambiguity around implementations. This is proper standards-based approach, but it's also, I think, again, to the point we made earlier, it's based on existing stuff. So the fact that RTP is the cornerstone of RIST is important to us because so much of our infrastructure as a major infrastructure provider like AWS already knows how to forward and handle RTP packets. We're not dealing with new low-level protocols that we have to figure out how to manage. So that just makes our ability to handle RIST traffic so much more, feasible. We like, for us, latency, it's an interesting one. I think, we talked a bit earlier about how deterministic latency is really probably the most important thing. But honestly, low latency is important too, right? I think if you think about content, nobody's going to say to you, oh, I would like my content to be delivered, as late as possible to the destination. They're always going to say,
everybody say that.
Right. So, always, if we could do it in zero time, I think, and reliably, of course, customers would love that. Unfortunately, the laws of physics prohibit that on a number of levels. And so we're reduced to milliseconds nonetheless. But I think, what we love about RIST is its ability to really provide that, to your point, that broadcast grade resilience without a huge amount of compromise in terms of latency. So that is very, very big for us. It's also a true transport protocol. It doesn't care about the underlying video itself, in the sense that it cares that it gets delivered, but it doesn't care, which formats it's in and how it's been encoded. That's very much an application decision, which again is really great from a broadcaster's perspective. And then I think and the last point I want to make about why it's important to us, and particularly the media services part of AWS, is that this has true community oversight and buy-in. And so this isn't one vendor coming to the community and saying, look, here's my solution, here's why I think you should use it, and it's really being developed by the community, including vendors that like Haivision, like Zigzee, who have their own proprietary ARQ-based protocols, but they're really investing in this protocol and the future of reliable TS as a community. And I think that is going to be that will be to the benefit of us all, as organizations, and of course as broadcasters, and for our customers as well.
Yeah, I'm a big believer in the open standards. It's a little frustrating sometimes. It can take a while to get 10 different people from 10 different companies to agree on the same thing, but you end up with something that's a lot more robust as a solution. Nobody wants to sign their name to a document that's got any missing parts or really falls short in different areas. So I think that's really it's a great benefit, but man, I'll tell you, sitting through some of those meetings sometimes is a little tedious.
Yeah, absolutely. No, but I think the end result is a good one, and I think one that will benefit us all because of that buy-in. I think there's nothing more certain of getting adoption and buying if people have a hand in helping build something, right? I think that's such an essential basis to adoption, and I think RIST has been exemplary in that respect, and its ability. I've been involved in some of those, especially in the early days, the early VSF meetings on RIST, and
remember
some of them, as you say, some of them are chaotic, but in the end what we did is what came out, I think, is something that we can all be proud of as an industry.
I think so too. So RIST and AWS Elemental Media Connect, pretty cool. So today we have the simple profile. And so, to your point earlier, I think what's great about simple profile is that it sets up the basis of the standard. The ARQ is in there. It's the core competencies of any reliable TS workflow are available inside of simple profile implementation. Of course, what comes next is really what puts RIST into its stride. It's the enterprise tier features that our customers are expecting. You mentioned, of course, encryption is a huge part of that. The content that our broadcasters are delivering, sometimes over the open internet, is worth money. It has value, and to have that just unprotected, flying around as bits and bytes is not desirable to any broadcaster, because for obvious reasons around theft and revenue protection. So bringing encryption to RIST, and I think the exciting news around the publishing of the main profile standard
really starts to put RIST into that, as I say, gets it into its stride and starts to make it super applicable for these like tier 1 broadcast distribution and contribution workflows. So naturally, as a product that is also in that reliable TS space, we want to adopt that into Media Connect as well. So, and I think the last thing I'd want to say about RIST, and particularly our interest in RIST, is that it's also a living standard, right? It's not not done and dusted. We're going to continue to, as a community, to build sophistication, and and I think what's great about it is because it's being developed in the here and now, in I think we could all agree, a particularly transformative time in our industry. It's so great to have a standard that's constantly being revised, that can adapt to meet the sometimes rapidly changing needs of our customers. And I think that's a really important thing. It's alive, right? It's a living, breathing standard that will continue to improve and meet the needs of our customers as they change over time.
I couldn't have said it better myself. That's absolutely true. Here's a couple references, and just thought we'd put those up right now before we get to the end, and then did want to jump in for a minute and talk about just a real simple, show you what we did on the interop. But the RIST specifications are open. They're free of charge. There's literally no licensing requirements in them. I mean, you have to read the IPR statement and things like that. You can see on this, where you can get these documents. Just go to vsf.tv and you can find them pretty quickly. We have an active group going on, continuing to advance the RIST cause. The next version of the specification will be called the Advanced Profile, and include some other interesting, bonus features for broadcasters and users alike. And there's a bunch of things that have been done that are available for people to watch. You can see the YouTube references here. In fact, one of the things I recommend for anybody that's interested in video technology is just subscribing to the VSF videos. That's capital V, capital S, capital F _ videos channel on YouTube. And there's almost 150 videos on there on all kinds of different topics. And there's definitely some good RIST forum information there. And of course, the RIST Forum, I don't want to undersell that. I mean, they are the ones who are continuing to carry the flag forward. The RIST Forum provides a lot of interaction between the members, and also helps get the message out about, some of the things going on with RIST. So here's a cloud demo that was done. And it's interesting to see, again, this demo was done virtually. It was done actually during the darkest days of the pandemic, well, hopefully the darkest days, I hope it doesn't get any darker, of the pandemic lockdowns in the United States. And you could see that we had global reach for these different signals coming in. We had participants from multiple continents using public internet services, feeding the videos into a centralized receive location at one of our active participants in the RIST Forum that had some server space and some bandwidth available to work all these different signals. And if you want to see a diagram of what the demonstration was, you could see all the different logos here are all different organizations that participated in doing this contribution video testing. You see at the very top LibRIST, which is the open source version of that. You can find GitHub resources with basically the source code for a very high quality RIST implementation. And then all of these other vendors working together, feeding their signals through public cloud and internet infrastructure and going into a data center. And the end result was literally hours and hours of live video or simulated live video without any packet losses that made their way all the way through to the finished video. RIST was able to correct all of the impairments that happened on the public internet from those different continents into the data center in Florida, and achieve perfect quality video. I mean, there were no detectable, there were no measurable defects of any kind of the final video that you see here showing on the multi-viewer. So I think that's pretty amazing. I mean, I'm not sure how many people have been able to do that over the years, on private circuits or satellite circuits, let alone trying to do that over the public internet. So that's, there's lots more information available about RIST. You can start looking at some of the products that have implemented it. Feel free to contact our organization, the RIST Forum, at info@rist.tv. We have a website that's growing, and as I mentioned, we're adding new members all the time. We'd love to have you join. We'd love to have you participate, and we'd love to have you in the audience take a look at the different technologies. And I'm sure we'd really love to have more people using this technology with products like Media Connect that can really tie all the loose ends together and get the video from one vendor to another, from one source to a destination. That's really, to me, that kind of infrastructure makes this all come alive.